This morning we're at a home in Horsham doing some landscape lighting work. Customer called and wanted to replace all of his landscape lighting. We're going to work with the existing wiring that's in place. However, there are some issues with some of the fixtures that prompted the reason for the replacement. And we can take a look at some of those now. This is one of the reasons that we're replacing some of these fixtures. The lens on this is melted. The bulb in here is too high a wattage for the plastic lens that's in place, and basically it just melted it. So this fixture, because the socket's compromised and the lens is melted, is really just no good anymore. This is another one of the fixtures that we'll be replacing. This is basically a well light with a par 36 bulb in it. All the existing bulbs in these systems, in this existing system, are halogen, and we're replacing everything in LED. The LED will reduce the heat that comes off the fixture and will also cut down on the operating cost substantially, as well as last a lot longer than the halogen bulbs do. In low voltage wiring, when the wire's buried, one of the key things that you're trying to protect against is corrosion of the wire. And there's a couple different ways to go about that. This is not one of them. These are just standard wire nuts that you would use for tying wires together in your house. And you can see that, you know, the wire started to corrode. You can see some of the discoloration in it. When the wire starts to corrode, it increases the amp draw. So if you're working with an older halogen system, that can cause the transformer to overload and create a problem. So what we do with fixtures like these, we're going to end up with a pigtail out of the new fixture. The wiring that's existing, that's staying in place, we'll strip the wires back, cut them clean, hot dip these connections in solder. So the wire gets stripped back, it is dipped in some flux. The flux helps clean the metal and get the solder worked throughout the entire twist of wire. We use basically two different types of wire. This one's the best. This is a tin-coated copper wire, which is more resistant to oxidation and corrosion than, say, just a plain copper wire. Both of these are equally strong in their connection, and this is just more resistant in case there should be any water and oxygen that get into the connection. So after it's soldered and cools down a little bit, we take a wire nut. Kind of looks similar to the other one except for the color. However, when you insert this in here and tighten it up, and it's very important to get these on tight so they stay, you'll see silicone oozes out from the connection. That ensures that we've got a pure, weather-tight, solid connection. Now, on this project, we're using the existing wiring and keeping that in place. The other option for wiring is a relatively new company out of Florida called Coastal Source, and they manufacture their wire with these ends on them. These are marine-grade connections, protected with O-rings, gold-plated pins. They have an audio system that uses the same wiring, and instead of carrying around a solder pot, these just connect like this, tighten them up, and you've got a weatherproof, fail-safe connection. The gauge of the wire, this wire has similar gauge wire to that, tin-coated copper. Each wire in here is wrapped in a jacket. Both of those wires are then protected by another jacket, and then everything's wrapped in another jacket that it makes it more cut resistant and abrasion resistant. The wire's more expensive, but in the long term, it's well worth the money.